All right, so today in geometry, we're looking at section 2.5 and the beginning of 2.6, reasoning with properties and proofs. So this first page just gives all these properties and postulates and definitions that are available to use for proofs that we are ready to start using. Okay? A lot of these we went over yesterday, so like the addition property of equality, subtraction property. Notice down here that we have now number 7, substitution property. That's the one that says that we can now no longer, the subtraction property, that's why we cannot do subtraction as SUB. Okay, we have to write out subtraction. Substitution, we have to write out substitution. So the substitution property just says if A equals B, then B can be replaced with A in any equation. So if C equals 5, then I can say A plus C equals A plus 5. I can replace, I can substitute that. The reflexive property, now we see that we have that with the congruence as well as the symmetric and the transitive property. Okay. Then all of these that we've already talked about, chapter 1 stuff, angle addition postulate, segment addition postulate, the supplementary angles definition, complementary angles definition, definition of the bisectors, definition of midpoint, perpendicular lines, congruent figures. Okay. So the congruent figures, we will use that one a lot, or you can call that the definition of congruence. That says two geometric figures are congruent if and only if they have the same measure or the same lengths. All right, so we're going to start out just justify each statement by naming the property, postulate, or definition demonstrated to get us used to all of these properties, recognizing them. So number 1, if 6x equals 36, then 36 equals 6x. So notice I have the exact same thing on both sides. It's just they've traded places. So this is the symmetric property, and then of equality. Okay, since I have equal signs over here, it's equality. All right, the next one, number 2, if x equals 18, 18 equals 13 plus 5, 13 plus 5 equals 17 plus 1, then x equals 17 plus 1. So this is like our chain rule, or the law of syllogism, where we started out with this, then this, then this, then this. So if the very first one happens, then the very last one happens. In a proof, this is called our transitive property. And again, I had to say of equality. All right, let's look at the back. So number 3, negative 3 parentheses, x minus y equals negative 3x plus 3y. This is the distributive property because we distributed. Number 4, if the measure of angle A plus the measure of angle B equals 180 degrees, then angle A and angle B are supplementary. This is the definition of supplementary angles. Number 5, if the measure of angle A equals measure of angle B, then angle A is congruent to angle B. This is the definition of congruence, or congruent figures. Okay, anytime that I want to change from an equals to a congruent is the definition of congruence. Number 6, if angle A and angle B are complementary, then the measure of angle A plus the measure of angle B equals 90 degrees. This is the definition of complementary angles. Number 7, if angle CAB is congruent to angle BAE, then ray AB bisects angle CAE. This is the definition of angle bisector, and you have to say what type of bisector it is, since we have a segment and an angle bisector. Number 8, AB equals AB. I have the exact same thing on both sides, so that is the reflexive property of equality. Again, it's equality because it was an equal sign. Number 9, the angle ABC is congruent to angle CBA. Okay? Notice that the B is in the same spot. It's my vertex. The A and the C are what traded places. So this is a symmetric property, this time of congruence, because it had a congruent symbol. Number 10, if AB equals CD, then AB plus BC equals CD plus BC. Okay? So they told me AB or CD. Okay? So we substituted. This is the substitution property. Okay? You can only use substitution if you have equal signs. So that's why we don't have of equality or congruence. So remember, substitution can only be used if there's an equal sign. 11. If x equals 8, 8 equals z, then x equals z. This is the transitive property of equality. Again, it's equality because I have equal signs. All right, so now we're going to complete the property. So now they're going to tell me the property, and we have to complete the statement. So reflexive property of equality, AB equals AB. You just need the exact same thing, right? Substitution property. If A plus B equals 20 and B equals 3, then A plus 3 equals 20. We substituted 3 for the B. Symmetric property. If BC equals RL, then, so symmetric, I just trade places. RL equals BC. Number 4, the addition property. If x equals y, then x plus 8 equals y plus 8. So the addition property, I'm just adding the exact same thing to both sides. Definition of congruence. Switch here to my pen. So definition of congruence. If measure of angle A equals measure of angle B, then angle A is congruent to angle B. Okay? So the definition of congruence, when I need to switch from equals to congruence. Number 6, definition of perpendicular. Okay, so definition of perpendicular. If G is perpendicular to K, then the two lines form right angles. Number 7, transitive property of congruence. Again, it's congruence because everything in here are congruent signs. If segment AB is congruent to segment CD is congruent to segment EF, then I can start out and I can say the very first one, segment AB, is congruent to the very last one, segment EF. All right, so again, now we are going to practice the proofs. Solve the equations in algebraic proof form. Again, I gave you all the statements. We're going to fill in the reasons. So the very first one, remember our very first reason is always given, no matter what. The second one, what did they do to the top equation to get the second equation? They distributed the 2. So this is the distributive property. What did they do to that equation to get the one below it? So I noticed that they went from 4x minus 6x to a negative 2x. They combined like terms. Remember, we said we could abbreviate that CLT. Now what did they do? They moved the 2x over. They did that by adding. So this is the addition property of equality. The next one, 2 equals x. This is the division property of equality. And finally, x equals 2. So they had to switch the order, and this is the symmetric property of equality. Okay. All right, so now let's look at the next one. So the first equation, okay, my reason, always given, whatever they give to me. The next one, what did they do to the top equation to get this next equation? So they moved the 12 to the other side. They did that by subtracting. So this is the subtraction property of equality. And finally, they have y equals 10x plus 4. So what did they do to get rid of the negative 3? They divided. So this is the division property of equality again. Okay. All right, let's look at the last page. Okay. So here, we want to go ahead and fill everything in. So now here they give me the very first one. So this is given. So I need to come over here and work the problem out. So the first thing I see is I have parentheses, so I have to distribute. So I would end up with 3x plus 2x minus 2 equals 8 plus 7x. And what did we do? We distributed. So this is the distributive property. Okay. All right, so now on the left-hand side, I have 3x plus 2x. I need to combine those to get 5x minus 2 equals 8x. I'm sorry, 8 plus 7x. We combine like terms, so this is CLT. I need to now get all of my x's on the same side, so I'm going to move my 7x over. When I do that, I end up with negative 2x minus 2 equals 8. How did I move the 7x over? I subtracted, so that's the subtraction property of equality. I need to now move the 2 over, the negative 2 over, so when I do that, I get negative 2x equals 10. I got rid of the negative 2 by adding 2, so that's the addition property of equality. And now, finally, I need to divide, and when I do, I get x equals negative 5 by the division property of equality. All right, so now we want to do everything on this one. Okay, so I'm going to switch back over to my pen. All right, so the very first thing, this first statement, we need to write what they give to me. So they give me 3x minus y equals 12, given. They also give me 2 parentheses y plus 4 equals 10, given. They want me to solve or show that x equals 13/3. So that top equation, the first one they gave me, had an x and a y in it. I need to first find out what y is, so then I can substitute that in. So I'm going to work with the second equation. I'm going to distribute my 2, so I'm going to get 2y plus 8 equals 10. My reason, distributive property. All right, now I need to move my 8 over. So when I do that, I get 2y equals 2. That is the subtraction property of equality. I divide and I get y equals 1. That's the division property of equality. So now that I know that y equals 1, I'm going to take that and I'm going to substitute in that top equation, the very first one. So I'm going to rewrite that 3x minus, instead of y, I'm going to substitute 1 equals 12. This is the substitution property. Remember, we can only use substitution when we have equal signs. So now I need to solve this equation. So I'm going to add 1 to both sides. So I get 3x equals 13. This is the addition property of equality. And finally divide by 3, and I get x equals 13/3, which was the division property of equality. All right, that is the second day of 2.5 and the first day of 2.6.